Hello to everyone. Welcome to our YouTube channel Sethi. In today's session 6 of current electricity, NEET numerical value type questions in which we have to fill in the blanks as simple numerical value. Application of KCL, KVL, capacitor in steady state through illustrations taken from JEE Main 2024. In earlier session we have studied different session 1, 2, 3, 4, 5. These concepts has been cleared through illustrations, which you can review on Sethi. In addition to this, I will also request go through these for JEE and for NEET. These very important concept killing videos on all the topics of +1 and +2 math and physics, all right, which you can review on Sethi Learn. Now let's start with the question. Question is, the current flowing through one of resistor is N by 10 ampere. Value of N we have to fill in the blanks. These questions numerical value type questions, right? Question is taken from JEE Main 2024. This is one of resistance. Current flowing through is N by 10 ampere. We have to fill in the blanks the value of N, right? Now let's start with the question. Concept applicable solution. One is KCL. One is KVL. Kirchhoff current law, Kirchhoff voltage law. It is based on conservation of charge. It is based on conservation of energy. KCL is summation I equal to 0. It is applicable at a junction. It is applicable at a junction. KVL is applicable at a loop. And also summation IR equal to summation E. Summation E, sign convention, leaving point of terminal is a sign. These are the basics of KCL and KVL, right? Now in this case, let point A voltage is V1, at point B, point C voltage is V2. This characteristic, this is 0 volt, this is at 5 volt, this is 0 volt for 5 volt. Now applying KCL at point A and C. Now first at point A. At point A. Point A में 5 minus V1, potential difference across the divided by the resistance 4 plus 0 minus V1 upon 4 plus V2 plus 10 minus V1 upon 1. This is V2 plus 10 minus V1 upon resistance equal to 0. Summation I equal to 0 or sum of incoming current equal to sum of outgoing currents. On simplification, we get 5 minus V1 plus 4 V2 plus 40 minus 4 V1 equal to 0. So this comes out to be 4 V2 minus 6 V1 equal to minus 35. This is equation 1. This is equation 1. Now applying KCL at point C. At point C. At point C में V2 minus 5 V2 minus 5 upon 2 equal to V2 minus 0 upon 2 equal to V2 equal to plus V2 plus 10 minus V1 upon 1 equal to 0, right? On simplification we get this is 0, V2 minus 5 plus V2 plus 2V2 plus 20 minus twice V1. On simplification we get 4V2 minus twice V1 equal to minus 15. This is equation 2. Equation 2. On solving 1 and 2, on solving equations 1 and 2, we get V1 equal to 7.5 volt and V2 equal to 0. Now, according to question, this is battery of 1 ohm resistance. Battery 1 ohm resistance, V1, V2, 7.5, 0, 10, current is like this. Current I is N by 10. So according to this, 0 plus 10 minus 7.5 upon 1 equal to N by 10. 2.5 equal to N by 10. And comes out to be 25. This is the so fill in the blanks is N equal to 25. Right? Simply applying the KCL at point A and at point C. Sum of incoming current is equal to sum of I current, so summation I equal to 0. We apply the concept of summation I equal to 0. Right? Now, next question. Question is, in an electric circuit drawn below, the amount of charge stored in the capacitor is, answer should be given in microcoulomb. Circuit is like this, 6 ohm, 10 ohm microfarad capacitor, R2 is 5 ohm, R1 is 4 ohm, 10 volt battery is connected. Question is taken from JEE Main 2024. Concept, applicability and solution. Concept, applicability and solution. In a steady state, capacitor behaves like open circuit. Then circuit reduces to, therefore, in a steady state, circuit reduces to 10 volt, 4 ohm, 6 ohm, 10 volt, R3, R, right? So current drawn from the battery, current drawn from cell equal to applied EMF 10 divided by 4 plus 6, that is 10 by 10, that is 1 ampere. That is 1 ampere. Right? Now, again, seeing the circuit, according to this, VR3 will be equal to VC plus VR2. In a steady state, VR2 will be equal to 0. So VC will be equal to VR3. VR3 means I into R3, 1 into R3. R3 is 6 volt. Now we have to find the charge enclosed. Amount of charge stored. Therefore, amount of charge stored equal to C into V. CV is 6 volt and that is 10 microfarad. This comes out to be 60 microcoulomb charge. That is our answer. Fill in the blanks will be 60 microcoulomb. Right? Now, next question. Question is, in the given circuit, the current flowing through resistance 20 ohm is 0.3 ampere, while ammeter reads 0.9 ampere. The value of R1 is, we have to fill in the blanks here. Question is taken from JEE Main 2024. Concept, applicable and solution. We know in parallel combination, potential difference is same across each combination, right? Say this is I, this is I1, this is I2, this is I3, this is I is given to 0.9 ampere, I is given to 0.9, I2 is given to you 0.3 ampere. I equal to I1 plus I2, 0.3 plus I3 equal to 0.9, means I1 plus I3 equal to 0.6 ampere. What relation is this? Another, you have to find the value of R1. In that case, say this is AB, CD, EF. According to this, VAB equal to VCD equal to VEF. That is I1 into R1 equal to I2 is 0.3 into 20 equal to I3 into 15. I2 into 15. Using this relation, I3 comes out to be 0.3 into 20 divided by 15. 10 to 0.4 ampere. I3 comes out to be 4 ampere. According to the relation I1 plus I3, I1 plus I3 equal to 0.6. I1 will become out to 0.6 minus I3, 0.4, that is 0.2 ampere. I1 comes out to be 0.2 ampere. Substituting here, now using this one, I1 0.2 into R1 equal to 0.3 into 20. R1 comes out to be 3 by 2 into 20. 10, that is 30 ohm. That is the value of R1. Fill in the blanks will be 30 ohm. Right? Now, simple apply the concept of potential difference in the parallel combination is same. Potential difference across AB equal to potential difference across CD equal to potential across UC. Applying also I into R, I into R, I into R. Applying the KCL here, I equal to I1 plus I2 plus I3. Some incoming currents at point C equal to outgoing currents. Right? Now, I will request, if you're new to my YouTube channel, Sethi, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you. धन्यवाद. बहुत बहुत धन्यवाद जी. बहुत बहुत धन्यवाद.